Alrighty, good morning. All right, let's get to it. Study guide, cool down 2.6. This particular video is geared to help you not only answer cool down 2.6 and, give you the thinking behind the solution, but to get you ready for this topic when it comes up on your final. So let's go ahead and jump into it. So we have the polynomial p of x equals x plus 6, x plus 3, x minus 5. Our first question is going to ask us to rewrite this polynomial in standard form. Right now it is in factored form because it is written out with factors. Standard form will have it laid out such that we have x cubed plus something x squared, plus something x to the 1 plus some constant at the end, some number. This is not the answer, I'm just giving you an example, okay? This is factored form versus standard form. In order to get this factored form into standard form, you can use the FOIL method and distributive property, but for the sake of footsteps, or I guess baby steps in the right direction, I'm going to use the box method. So what I'm trying to say is you don't have to use a box method in order to complete this problem. Use whatever works for you. I just feel the box method is a great tool for beginners to organize their work, to organize their thinking into ways that the work doesn't wind up all over the place, unorganized. And then you can imagine when someone's at the beginning stages of learning how to do this, having work over here, over there, and then just getting lost. It's not the fun experience I wish for my students. So that's my logic behind why I'm using the box method and why I insist on teaching with it. However, I am open to the idea of my personal method is FOIL. So just so we put that out there. So let's get going. So my recommendation is to multiply the first two binomials, x plus 6, x plus 3. You can use the box method for that, which I will place, let's say down here. I think that worked out nicely in the other video. X plus 6 goes on top. Actually, let me not draw the squares, because some people are asking me, Mister, how do you know how many squares you need for the box? Do you need 6? Do you need 8? Do you need 12? So let me actually just write out the binomials. Okay, then I'll show you how I know. So between x and 6, I'm going to place a line. Between x and 3, I'm going to place a line. And that's why you get 4 squares. Now, in order to fill this space in, you're going to multiply x times x, which is x squared. Then you're going to multiply x times 6, which is 6x. 3 times x, which is 3x. 3 times 6, which is 18. Then we write out the slanted circle to remind ourselves that the diagonals of this square are like terms which can be added and combined. So 3x plus 6x give us 9x plus 18. You will notice the two terms that were not circled are simply placed on the edges because nothing was combined, therefore nothing was changed, and we can simply just put it there in the resulting product. The two terms in the middle, literally in the middle. So now we know that x plus 6 multiplied by x plus 3 give us x squared plus 9x plus 18. And that's exactly what I'm going to write right beneath it to show my audience that the product of these two binomials gave me the trinomial that I'm writing right now. That is done. So next, I'm going to place the trinomial inside of parentheses. This is of great use to keep your work organized. Otherwise, you're going to have terms everywhere. And if you put them in a nice little bag, a pocket, it's very convenient for organization's sake. Okay, I'm going to now erase this. If it were a long piece of paper, I'd keep it there. But, this board is not infinite. And even if it was, I don't think the camera angle would be. That sounds like a great idea. Be the first person to create an infinite whiteboard and an infinite camera, and then the implications could be huge. But we can dream. And hopefully one day they're all like, oh, this guy predicted the future. Anyway, back to the problem. So again, I'm going to write down the trinomial terms at the top of the rectangle. And I'm going to write the terms of the binomial on the side. Okay, then you will notice I'm going to draw a line between these two values right there, between these two values right there, between these two values right there. Okay, so I didn't know I was going to get 6 squares if I'm a beginner, but I do know that if I follow the steps where I draw lines between the terms, it will work itself out. So now I do have 6 squares to operate with. Okay, so same thing as the other one where we fill in the squares. X times x squared, that's 1x, that's 2 x's, therefore we have 3 x's now, x cubed. We have 2 x's here, x squared, and the 9. Here we have x and 18, that's 18x when multiplied. So remember, we're multiplying to get these squares filled in, the edges of the squares, okay? Negative 5 times x squared is negative 5x squared. Negative 5 times 9x. So these two constants multiply to give you negative 45 x, and then negative 5 times 18. What does that give us? I don't know. Let's go ahead and do it on the side. 18 times 5, 0, 4, 90, negative 90. There we are. Okay, now like I did on the last situation, I'm going to circle the diagonal values. So I know that if I were to combine 9x and add it to negative 5x, so I'll do it right here. That would give me 4x squared. Okay, let me go to what color can I use here? Pink. Yeah, that's fine. Place that up there. Okay. Now we're going to combine the like terms, negative 45x plus 18x. Notice that the order in which you write these does not matter. Negative 45 plus 18. And there's a couple of different ways you can approach this. You can type into a calculator negative 45 plus 18, or what I'm going to do right now is actually push 18 and subtract 45. And it's going to give me negative 27x. There we go. So I'm going to write these, because I'm going to erase this right now. I'm going to write these values right here. So these two like terms, which are x squared like terms, gave me 4x squared. And these two like terms, which are negative 45x and 18x, gave me negative 27x. And there's the math right there. But I do have to erase it to provide space for myself. Okay. So the product of this trinomial and this binomial are all here. So I'm going to write the x cubed here. I'm going to write the negative 90 at the very end. Nothing has been done with these uncircled values. They just stay the same. Leave them alone. Okay. Okay, now the 4x squared was a positive 4x squared. And the negative 27x was negative. Okay, so we are done multiplying and showing our calculations here. And there was 2 boxes that we had to create. Now the last part of this cool down is going to ask you to determine the degree of this polynomial. So I'm going to erase this lovely box. Okay, so in order to determine the degree, let me write degree of the polynomial, you need to look at all the x's, or sometimes they have other variables like an a or a b or a c, but basically identify the variables. The variables are x. I'm going to put a little invisible 1, make it visible. So I have x to the 1, x to the 2, x to the 3. Then I need to think to myself, out of those 3 variables, which one has the highest valued exponent? 1, 2, or 3? Which one's the biggest? 3. The degree of this polynomial is 3. Next, in order to determine the constant value, and the constant value so happens to also be your y-intercept. I like to just continue using vocabulary. But it's called the constant on the coolant, but it's also known as a y-intercept or the vertical intercept, if you really want to know that too. Lots of words. Many students put 90 for this, but be careful. You're subtracting 90, so the constant is actually negative 90. All right, so a quick rundown on what we did here, okay? We used a 4 box to multiply these two values and get the blue one. We used a 6 box to multiply these two values and get the final polynomial here. All that work, if you rewind the video, will be available to you. Then we had to determine the degree, and we determined the value of the constant. All right, that's it. Good luck.